What goes up must come down, right? Well, not always. Hey there, space cadets. Ever wondered why astronauts look like they're floating in space? It's a fascinating phenomenon that has intrigued scientists and space enthusiasts alike for decades. It's not about zero gravity, it's about falling forever. Surprising, right? Let's dive in. When astronauts are in orbit, they are actually in a state of continuous freefall towards Earth. But because they are moving forward at such a high speed, they keep missing it. You know how when you jump, you come back down? That's because gravity is pulling you back towards the ground. It's a force that acts on all objects with mass. That's gravity pulling you towards Earth. It's the same force that keeps the planets in our solar system in orbit around the sun. What if you could fall and never hit the ground? That's essentially what orbiting is. It's a delicate balance between gravity pulling you in and your forward motion keeping you from crashing. That's what's happening with astronauts. They're in a constant state of free fall, creating the sensation of weightlessness. This unique environment allows them to conduct experiments that would be impossible on Earth. So next time you see an astronaut floating in space, remember, they're not defying gravity, they're riding it. The loop around Earth is called an orbit. An orbit is a fascinating phenomenon where an object in space follows a curved path around a planet or a star. It's a delicate balance of forces that keeps satellites, moons, and even space stations in a continuous journey around our planet. It's like a dance between gravity and speed. Gravity pulls the object towards the Earth while its speed propels it forward. This creates a constant free fall towards the planet, but because of the forward momentum, the object keeps missing it, resulting in a stable orbit. Gravity wants to pull the astronauts down, but their horizontal speed makes them miss. Inside the International Space Station, astronauts experience microgravity, which makes them feel weightless. They are essentially falling around the Earth, but never hitting it, creating a unique environment for scientific experiments and daily life in space. It's this perfect balance that keeps things in orbit. The balance between gravitational pull and the object's velocity ensures that the orbit remains stable. If the speed were to decrease, the object would spiral towards the Earth. If it increased, it could escape into space.
Think about swinging a ball on a string. The tension in the string acts like gravity, pulling the ball towards the center. The ball's speed keeps it moving in a circular path, just like an object in orbit. The string pulls the ball inwards, just like gravity, creating a centripetal force that keeps the ball moving in a circle. Without this force, the ball would fly off in a straight line, while the ball's momentum keeps it moving in a circle. This is similar to how the momentum of a satellite or space station keeps it in orbit around the Earth. The International Space Station works the same way, just on a much larger scale. It orbits the Earth at a speed of about 28,000 kilometers per hour, completing one orbit approximately every 90 minutes. This incredible speed, combined with the Earth's gravitational pull, keeps the space station in a continuous free fall around our planet, allowing astronauts to live and work in space.
Now let's talk about Galileo Galilei. Galileo was an Italian astronomer, physicist, and engineer, sometimes described as a polymath. He played a major role in the scientific revolution of the 17th century. His contributions to observational astronomy include the telescopic confirmation of the phases of Venus, the discovery of the 4 largest satellites of Jupiter, and the observation and analysis of sunspots.
He figured out that objects fall at the same rate, regardless of their weight. This was a groundbreaking realization that challenged the long-held beliefs of Aristotle, who thought heavier objects fell faster than lighter ones. Galileo's insight laid the groundwork for the laws of motion that Isaac Newton would later formalize.
He couldn't test it on Earth because of air resistance, but guess what? Air resistance affects how objects fall, making it difficult to observe the true nature of gravity. On Earth, a feather will fall slower than a hammer because the air pushes against it more.
Astronauts did it on the moon. The moon has no atmosphere, which means there's no air resistance to interfere with falling objects. This provided a perfect environment to test Galileo's theory.
They dropped a feather and a hammer at the same time. And guess what? This experiment was conducted during the Apollo 15 mission by astronaut David Scott. He held a feather in one hand and a hammer in the other and released them simultaneously.
They landed at the same time. This visually confirmed Galileo's hypothesis that in the absence of air resistance, all objects fall at the same rate regardless of their mass.
No air resistance on the moon, so everything falls at the same rate. This experiment was a powerful demonstration of the principles of physics and a testament to human curiosity and ingenuity.
Pretty neat, right? It's amazing how a theory proposed centuries ago was finally proven on the moon, showing the timeless nature of scientific inquiry and discovery.
Here is a fun fact for you. Did you know that astronauts' height can increase by up to 2 inches while they are in space due to the lack of gravity? When astronauts are on Earth, gravity compresses their spine, just like it does for all of us. However, in the microgravity environment of space, this compression is relieved, allowing the vertebrae in their spine to expand. This is why astronauts can gain a noticeable amount of height during their missions. But don't worry, this increase in height is temporary. Once they return to Earth and gravity starts to take its toll again, they shrink back to their normal height. This phenomenon is not just a fun fact. It has important implications for the health and well-being of astronauts. Scientists study these changes to understand how long-term space travel affects the human body and to develop countermeasures to mitigate any negative effects. From special exercises to advanced suits, various strategies are employed to keep astronauts healthy and fit during their missions. Love discovering cool facts? Hit like, share, and subscribe for more mind-blowing surprises. Until next time, keep exploring.